Hello, welcome to 6.2. Today we are talking about analyzing discrete random variables. So last class we talked about random variables and setting up probability distributions, being able to find probabilities. So now when we're analyzing it, we want to look at things like the mean and standard deviation of a discrete random variable. So just a reminder, the discrete random variable was the ones where we could make the table for, the probability distributions where the x values could only be whole numbers. So we'll start by calculating a mean. Remember, this is it's kind of weird because we have like a whole table that we're trying to find a mean for. So the formula for it is a little weird. But when we calculate a mean of a discrete random variable, this is really what the number means when we get a number at the end. So because it's a mean, it's really an average value. But for a discrete random variable, we were saying this is if you were to do a chance process a bunch of times, and then from that chance process, whatever results you get, this becomes the average of doing that a bunch of times. Another way you'll hear it asked is like if we're trying to find an expected value. So if we were to roll a die a bunch of times, what number would we expect to land on for the average? Something like that. The formula looks like this. Sigma, which means to take the sum of x times p. So basically, in a probability distribution, you're going to take each value, multiply the value by the probability, whatever number you get. You're going to do that for all of the values that you have in the table, add them all up. That's all you're doing. So here's our example. C is going to stand for the random variable of the total cost of a cruise package from Carnival. Calculate the expected value of C. So all our values are the 300, 450, 600, 750, 900, and all our probabilities are below them. So we would multiply the 300 times the 0.15, the 450 times the 0.25, and so on. Whatever you get from multiplying, you add them all up. If we did that, then we would end up with 562.5. So basically we're saying if we wanted to do this a bunch of times, like purchase a total cost of a cruise package from Carnival a bunch of times, the average amount that we would pay would be $562.50 out of all the different packages and the probabilities that people buy them at. So obviously not too bad to do by hand, but of course we are lazy statistics people, so we will also be able to do this in the calculator. With the mean, I don't know if either way is faster or slower, but at least you have those steps for the calculator if you want. So here we go. Here's my handy dandy calculator. So the first thing we're going to do is go into our list. So remember that's the stat, edit. So in L1 we're going to put all our values. So the 300, the 450, and so on. In L2 is where we're going to put all our probabilities. So make sure you type them in order. Now that I have all my L1 and L2 values inputted, I'm going to go into L3. So remember, our goal was to take all of our values and multiply them by our probabilities. So all my values are in L1. I'm going to multiply them by everything in L2. So remember, to do that, you need to scroll all the way up to L3 first, and then type in L1 times L2, enter. Okay, so it did all the multiplication for us. So now we just need to add all these up. So remember, to get to sum, we need to go back to our home screen first. So second mode to get back to the home screen. And then second stat, go over to math. And then number 5 should be sum. We are taking the sum of everything in L3. Hit enter, and there's our mean. Yay! We also want to be able to calculate the standard deviation of a discrete random variable. So remember, standard deviation usually talks about how spread out your data is. So here we are kind of talking about how spread out all our values are based on the probability amounts as well. Because if you have like a higher probability for a certain one of your numbers, then that increases the spread for that particular number. So when we talk about standard deviation and like what it means, we're really talking about how much each value in the random variable typically varies from the mean over many repetitions of a chance process. So again, we're talking about the standard deviation as something that happens after we do things a lot of times, whatever chance process it is. But standard deviation, because it's talking about like how spread out things are, this is like how much it typically varies from the mean. How much is it different from the mean? Because remember, the general standard deviation definition was that it's like the average distance that each data value you have is from the mean, from the average. So it's similar here. All right, so the formula looks like this. Basically, you're going to take each value that you have, subtract it from the mean, which means you have to find the mean first, which is good that we did it in our calculator because it's already there. Then after you subtract, you're going to square it, and then take that number, multiply by the probability. You're going to do that for every single value that you have in your probability distribution, add everything up, and then finally take the square root. So this is more complicated to do without a calculator. So we're going to rely on a calculator for this. In your lists, you should already have your data in there, which is, again, why it's nice to do the mean in the calculator as well. So we already have our L1 with our values, L2 with our probabilities. So we're going to use L4 to do the part where we're going to take each value, subtract the mean, and square it. So we're going to type in our values, which is everything in L1, subtract it from the mean. So we got a mean of 562.5 earlier. So that's something you have to remember to write down. Square it, and then multiply by the probabilities, which was everything in L2. Okay, so we've typed that into our calculator, hit enter. We get a bunch of big numbers. Fine. But we're going to add everything up here, so we're going to do sum of L4. So let me get back into my home screen. So second mode, second stat, go over to math to get to sum of L4, hit enter. So that's what I get when I add everything up, but then we're going to take the square root of this number, and that'll give us the standard deviation. So square root of the answer I just got, or if you want to copy paste by scrolling up and hitting enter, we get 163.46 if we round to 2 decimal places. Alright, so just writing out my calculator steps right here, we end up with our standard deviation of 163.46 if we round to 2 decimal places. And that's how you're calculating the standard deviation. I've got one last example for us to do. So here we're talking about a life insurance company that sells life insurance to 21-year-old males. It'll pay $100,000 if the male dies within the next 5 years, which is pretty solid. But life insurance to a 21-year-old male, the company usually earns a lot of money from that because most 21-year-olds, even within the next 5 years, will not be very likely to die. So that's why the payout's not that much. So whenever you buy life insurance, you're pretty much betting on yourself and your death. Kind of morbid. But here are the probabilities that a randomly chosen male will die each year based on their age. The company collects a premium of $250 each year as payment for the insurance. The amount Y that the company earns on a randomly selected policy of this type is $250 per year, less the $100,000 that they must pay if the insured dies. So basically, the insurance company is earning a bunch of money, unless they actually die and then they have to pay a lot. Here's the probability distribution of Y. So here, this is all based off of the profit that the company makes. So if the male dies at 21, then the company would actually lose $99,750 because the insured person would have paid $250, but then the company would have paid out the $100,000 for their death. In year 2, though, the person who died would have paid $500 total now, because $250 for each year. So $250 when they were 21, $250 when they're 22, and then if they died at 22, then the insurance company would have given them the $100,000. So really the company would have just lost out on $99,500, and so on. But the probabilities, you look at them, probability of a 21-year-old dying is really, really low. Same thing with a 22-year-old, 23-year-old, and so on. If you make it to year 26, then this is how much the company earns, $1,250, because that's how much the insurance would have cost the person who didn't die. Every year they would have paid the $250, and the probability of that happening is pretty high, because if you're a 26-year-old, you're pretty likely to survive. There's not a whole lot of illnesses or anything that you would have died from. So here, we're going to try to calculate and interpret the mean of y, and then we're also going to calculate and interpret the standard deviation. I'm going to do everything in the calculator today, so if you have stuff in your lists already and you want to clear everything out really quickly, remember we can do second plus sign number 4. We'll clear all lists, hit enter, and then it's done. So now when you go into your list, everything should be clear, and we can start typing in our new data. So we are looking at the profit along with its probability to talk about the amount that the company would earn. So our first number is going to be the negative 99,750, and so on. Okay, so I've got everything in L1, L2. So now to calculate our mean, we're going to go over to L3 and type in L1 times L2. We get all our numbers, and then we're going to add everything up. So second mode to get out, second stat, go over to math, number 5. Sum of L3 gets us 303.35 if we round to 2 decimal places. And we're talking about money here, so 2 decimal places makes the most sense. So here's our mean of $303.35. What this means is that, remember we said the mean is if you did many repetitions of a chance process, in this case selling insurance policies. So after selling many insurance policies, the company is going to profit an average of $303.35 per insurance policy sold. So obviously it's an insurance company, they're going to profit, but if you happen to die, then you do get paid out a lot, so that's kind of nice. But overall, they're kind of banking on you not dying within the 5 years, so that's how they profit $303 for every insurance policy that they sell. So let's move on to the standard deviation. So back to the calculator. We're going to scroll over to L4 and then scroll all the way up so that L4 is highlighted before we start typing in. So we want to take each of our values, which was in L1, minus the mean. So we got 303.35. After you subtract, you square it, and then times it by all your probabilities, which was in L2. Hit enter. Cool, we got all our numbers. Now we're going to go to sum everything up in L4. So second mode, second stat, sum L4, some giant number. We square root this in order to get our standard deviation. Comes out to be $9,707.57 if we round to 2 decimal places. So our standard deviation, we got $9,707.57. What this would mean if we were to interpret this is for the company, their profit would typically vary from the mean of $303.35 by $9,707.57, which is like a really big range here because we're really spread out. If you look at all of our numbers, their profits versus like we have a bunch of like really big numbers that are negative and then one really small positive number. So we have a big range of numbers, and that's how we got such a big distance. Remember that standard deviation is that average distance, and so it's kind of all really spread out. But that's how variable insurance is going to be. So that's it for 6.2. Thanks for watching.